In today's video, we are going to learn about what is data structure and algorithms and how can we master data structures and algorithms in few easy steps. Data structures. As per the name itself indicates that organizing the data in a structured manner in memory. It is very important for software to organize the data in a structured manner. As coming to the definition, data structures are methods for organizing and storing data in a way that allows efficient access, manipulation, and retrieval of data. Coming to the examples, arrays, linked lists, tags, queues, trees, and graphs are the examples of data structure. The purpose of data structures is to help to manage the data efficiently, enabling faster operations and better memory usage. After knowing this, you may have a doubt that what is the need of data structures in today's software industries. As you people know, applications are getting complex and the amount of data that is generated is increasing day by day. And many problems involving processor speed, data structure, and multiple requests to handle is getting worse. To solve these problems, data structures are used. In data structures, data is organized in such a way that all items are not required to be searched and the required data can be searched instantly. The advantages of using data structure is it is very efficient and reusable, which means that the data structure provides reusability and multiple client programs can use the data structure. Now I will tell you how software technologies are using data structures in their applications. Arrays. Arrays is a collection of similar kinds of elements, each identified by an index array key. And an array is a linear data structure and it is a collection of items stored at continuous memory locations. The idea is to store multiple items of same type of data together in one place. It allows the processing of large amount of data in a relatively short period. And there are different operations possible in an array like searching, sorting, inserting, reversing and deleting. And these arrays have significant applications in software development. If we wish to store the contacts on our phone, then the software will simply place all our contacts in an array. Like this, there are many more applications of arrays in software industry. Moving on to linked list. A linked list is a sequence of nodes where each node points to the next one. And it has different kinds of applications. We can see linked list applications in our daily life. For example, if we are in a web page, at the bottom of the web page or at the top, we can access the previous and next page URLs which are linked using the linked list only. And the music players also use the same technique to switch between music. Before going to other data structures, if you like the content of this video, click on that subscribe button. Next, we will explore stack data structure. Stack is a linear data structure that follows a particular order in which the operations are performed. The order is LIFO, last in first out. Entering and retrieving data is possible from only one end. And there are different operations possible in a stack like pushing the data, popping the data, sorting and deleting the middle element of the stack, etc. Coming to the different applications of stack in software technologies, we can see them in call logs, emails, Google Photos, YouTube downloads, notifications. In this, we can see the latest appears first, which is the stack structure that is a last in first out. And the stack data structure is widely used in evaluation and conversion of arithmetic expressions. Let's see how the data is organized in queues. Queue is a linear data structure that follows a particular order in which the operations are performed. The order is first in first out, that is, the data items stored first will be accessed first. Unlike stack, the entering and retrieving of data is not done from only one end. Few basic operations performed in queue are enqueue, dequeue, front, rear, etc. Coming to different applications of queue, to send an email, queue data structure is used. And in social media also, to upload multiple photos or videos, queue is used. Moving on to trees now. A tree is a non-linear data structure where the elements are arranged in a hierarchical tree-like structure. In a tree, it has nodes which contain some data and the data that is stored in it can be of any type. Different tree data structures allows quicker and easier access to the data as it is a non-linear data structure. And a tree has various terminologies like node, root, edge, height of the tree, degree of the tree, etc. Last but not least, let's explore graphs. A graph is a non-linear data structure that consists of vertices and edges. The graph is used to solve the most challenging and complex problems in programming language. And it has different terminologies which are path, degree, adjacent vertices, etc. One of the most common real-world application of graphs is Google Maps, where cities are located as vertices and paths are connected to those vertices are located as edges of the graphs. And another application is a social network, where every person on the network is a node and all of their friendships on the network are the edges of the graph. Like these, data structures can have various types of applications in the real world scenarios. So it is important to learn data structures. Now that we have covered the data structures, let's see how they are used with the algorithms. Algorithms are step-by-step instructions for solving specific problems or achieving goals. Based on the type of nature and usage, the algorithms are grouped together into several categories such as sorting algorithms, searching algorithms, greedy algorithms, dynamic programming algorithms, backtracking algorithms, and graph algorithms. And these algorithms have various applications from GPS navigation to recommendation systems. Coming to the different categories of algorithms, searching algorithms are used to locate specific elements in a data structure. Most common searching algorithms are linear search, binary search, and ternary search. Sorting algorithms. Sorting algorithms are used to arrange the elements in a specific order, such as numeric or alphabetical. It organizes the items in such a way that it makes it easier to search for and access specific elements. There are a lot of different types of sorting algorithms. Some widely used sorting algorithms are bubble sort, selection sort, insertion sort, quick sort, and merge sort. Next, moving to greedy algorithms. As the name suggests, this algorithm builds up to the solution one piece at a time and chooses the next piece which gives the most obvious and immediate benefit. That is, it makes locally optimal choices at each step. Some important problem of greedy algorithms are Naxap problems, Digitro's algorithm, Kruskal's algorithm, and Huffman coding. Next, dynamic programming. Dynamic programming is a method used in mathematics and computer science to solve complex problems by breaking them down into simpler subproblems. By solving each subproblem only once and storing the results, it avoids redundant computations, leading to more efficient solutions for a wide range of problems. Some important and most common problems of dynamic programming algorithms are Fibonacci sequence, 0 by 1 knapsack problems, longest palindrome sequence, and minimum cost path, etc. Next, moving on to backtracking algorithm. The backtracking algorithm is derived from the recursion algorithm with the option to revert if a recursive solution fails. That is, in case a solution fails, the program tracks back to the moment where it failed and builds on another solution. So basically, it explores all the possible solutions until it finds the correct one. Some important problems of backtracking algorithms are Knight's tour problem, rat in image, n-queens problem, Sudoku, etc. Last but not least, graph algorithms. Graph algorithms in data structure and algorithms are set of techniques and methods used to solve problems related to graphs, which are a collection of nodes and edges. These algorithms are designed to perform various operations on graphs such as searching, traversing, finding the shortest path, and determining connectivity. They are essential for solving a wide range of real world problems, including network routing, social network analysis, and resource allocation. Coming on to the path on how to excel at DSA, I suggest you to follow these 4 steps to learn DSA easily. Learn at least one programming language, example Python, which is booming in 2024, and learn about complexities and learn about data structures and algorithms. Finally, which is the most important step, practice data structures and algorithms. And if you think why should I subscribe to this channel, I am going to cover Python language and I am going to give a complete overview on data structures and algorithms with clear animation effects of how the algorithm works. So subscribe to this channel now.